Hi everyone, Ann Lemons here. I am really excited to be joined by my husband, Dr. Mark Lemons. He's agreed to come on and just answer some questions about the vaccines. Those are coming up in my practice. I know they're coming up in his practice. And just a little disclaimer, this is for educational purposes only. You can find more information at cdc.gov. And we're not advocating for or against the vaccine, we're just giving information. So I'd like to start with the first question, which is, what are the vaccines that are currently available right now in the US, and what makes them different from each other?
Well, let me answer that by first saying thanks for having me. And then secondly, the two vaccines that are presently available are the Moderna vaccine, and the second vaccine is the Pfizer-BioNTech vaccine.
Great. And are they different? How are they different from each other?
I think they're actually quite similar. They both use the mRNA technology. They both contain similar ingredients. There's a bit of a change in the lipid compound of the Moderna vaccine, so it can be stored at not as low of temperatures compared to the Pfizer-BioNTech.
Okay. And how effective are they? Are there differences in their effectiveness from one of the vaccines to the other?
Well, and the way they investigated the effectiveness is they wanted to see what percentage of people who received the vaccine develop an antibody response. So they would have their two vaccines, one over 3 weeks apart, the second one over 4 weeks, and then they would draw their blood probably 2 weeks or 4 weeks after that to see what percentage of people who received the two vaccines developed a qualitative antibody response. And the answer that we've been reading about is both vaccines were able to generate an effective antibody response in 95% of the people who received both doses. That's pretty remarkable.
Right. So it's just measuring that they had an antibody response, not how much antibody. So it's not measuring the quantity, just that it's saying, yes, you have received an antibody response from this.
Yes, and specifically antibody response against the M protein spike of COVID-19 virus.
Okay. So can you give us, and is there a simple answer to this on how they work? How do they actually work in our body to create that protection?
So all vaccines work in a similar way. The body's immune system is triggered and recognizes a foreign substance and then goes to work. And it generates two types of an immune response. We call it the cell-mediated response, and then the humoral or the antibody-related response. But it's designed to trigger both, and when both work in harmony, we have much greater success in fighting off the virus.
Awesome. So with this mRNA that we're talking about, it doesn't go into our DNA, so it can't change our genetic material. Is that right?
That's correct. So the engine of the cell is in the nucleus. The messenger RNA lives in the cytoplasm, which is sort of the furnace where proteins and things are made in the cells. And so what we're trying to do, or what these companies are doing, is incorporating the messenger RNA in the cytoplasm. It never enters the cell nucleus, so it's not going to change RNA DNAs.
That's great. Great news for us to hear that. And this technology, mRNA, it's not new, correct? We've had this around for a while.
Boy, I think it's half my age. The science started 30 years ago, so there you go. You know my age. And it's been really progressive. The speed at which the technology has advanced and the science has advanced is remarkable. And one may have heard the Zika virus that we heard about a few years ago. I think the NIH was working a lot with messenger RNA to try to develop a vaccine for the Zika virus.
So interesting. And do you think this is the kind of technology that will start going more toward in terms of just our regular vaccinations that we get? Can you see them changing to this type of technology? Is that something you see?
So that's a great question. So you have this old engine in this way that vaccines were produced via, whether in hen eggs or human diploid cells, and they were mass produced through that vehicle. This is a new technology you're not risking any contaminants with egg products. You're not having to deal with human cell DNA. So it's quite possible that this will be the vaccine development technique for the foreseeable future.
Very cool. All right, so let's talk about the other ingredients in the vaccine in terms of preservatives or adjuvants. What's in the vaccine in that regard?
So from what I've read, there are no adjuvants in these two vaccines, and adjuvants are ingredients to stimulate the immune system to create a greater response. And one may have read about mercury in some of the vaccines previously, or aluminum in the vaccines, and those are considered adjuvants to accelerate or increase the immune response. From my reading, there are no adjuvants in either the Pfizer vaccine nor the Moderna vaccine. They do carry lipids or cholesterol, which is a vehicle to help in the delivery system of the vaccine into the human body. And then there is a liquid component called polyethylene glycol in liquid form. Those of you who have heard about Miralax, that's a powdered form of polyethylene glycol, so a very common product.
Right, petroleum derivative.
And then the other ingredient would be a form of sugar called sucrose. Those are the four main ingredients.
Okay. Well, nice to hear that the adjuvants are not in there, so that's a bonus, I think. So side effects, what's considered normal, what's not normal?
Well, similar to a virus, but probably a much less response. So ordinarily it might cause chills, low-grade fever, injection site soreness, occasionally fatigue, body aches. I think those would be the primary 5 sort of side effects.
So you have had your first vaccination. Do you care to share some of your experience after being vaccinated?
Well, I got my vaccination on January 7th because I was considered on the front lines in working in the emergency department. So I did receive my vaccine, the Pfizer vaccine, on January 7th. As a matter of fact, I wasn't sure I received it. It was so painless. It was remarkable. The following day, I had a little bit of soreness. I did not have a fever. I did not have headaches or body aches. But I had a funny sensation in the back of my throat, and the mucous membrane that is from the soft palate of the back of the throat, called the uvula, was a tiny bit swollen. But I thought it was a pretty minor reaction. I didn't have to take any medication for it.
So does that give you pause for receiving the second one, or what are your thoughts about that?
So that's a great question. So most of the severe allergic reactions would really occur in the first 15 or 20 minutes. So if you might think about a bee sting, and some people who are highly allergic to bee stings, within 15 minutes they have hives, they have wheezing, they have shortness of breath, stomach aches, nausea, vomiting, low blood pressure. Those are called severe type 1 anaphylactic reactions. There are then type 2, 3, and 4 allergic reactions, and I would say mine was a type 2, a delayed reaction. And most of those would be a delayed, so maybe hives the following day. Not immediately, but it occurred the following day. Or lip swelling. But when it involves mucous membranes, it's a little bit of a more severe reaction. So it gives me pause or some trepidation on what do I need to prepare for my second dose of the vaccine. And in that case, I'll probably speak to my allergist at our hospital to talk about whether I need to be pre-treated with like an antihistamine or have an EpiPen nearby. So I have to make that decision, and I'll make that decision when I have all the information.
So do you think it might be worthwhile to see if you have did you have any antibody response after that first vaccine?
So that's a really great question, and there's a lot of debate or question circulating now in the literature, in the medical literature as well. And most of these study designs were based upon 2 vaccines, but there are people who have been tested after 1 vaccine, and I'm not exactly sure why there was a delay or a pause in the second dose. But there have been reports of an antibody response of somewhere between 52% and 84%. So I am considering asking my primary care physician to order a serum antibody test to see if I've actually developed the antibodies. And if I have a great response, then I can, that's more information that I'll keep before I decide on the second dose of the vaccine.
Great. So more information is always helpful. All right. And then just to close up, as far as best practices for everyone still, what do you recommend?
Well, the best practices, and to be honest, I think we should have done this more often with every influenza season. And that is probably wearing a mask when we're indoors or we're clinically at work in the emergency department or in some of the clinics. But it's the simple things that we try to teach our families and our children. Cough etiquette, cough into your sleeve, wash your hands frequently. I think some of those simple things can go a long way, particularly indoors.
Great advice. Okay, so thank you, everyone. That's it for now. We really appreciate you being here with us today. If you like it, let us know, and feel free to share as well. So thank you again to Dr. Lemons for taking the time out of his day to be with us.
You're welcome. Thank you for inviting me.
Until next time, thanks. Bye-bye.